Max Planck, IB level advanced topic, applied math solving for energy, wavelength, and frequency in the electromagnetic spectrum using speed of light and Planck's constant. So to solve these problems, what equations do we need to know? Well, first we need to understand what Max Planck gave us. He theorized that energy was transferred in chunks known as quanta, which is equal to h nu, which is Planck's constant times frequency. The variable h is a constant equal to 6.63 times 10 to the minus 34 joules times seconds. And the variable nu, or v, represents the frequency in per seconds, or hertz. This equation allows us to calculate the energy of photons given their frequency. If the wavelength is given, the energy can be determined by first using the wave equation. The speed of light is equal to lambda times nu, or wavelength times frequency, to find the frequency, and using Planck's equation to calculate energy. We've been using the strategy of triangles to help us solve for different word problems. There are some triangles that could be useful in doing these calculations. The first one is energy. And energy is equal to Planck's constant times the frequency. Triangle for this look like this. So in other words, if we want to calculate for energy, we're going to multiply Planck's constant times the frequency. If we want to know frequency, we would take the energy and divide by Planck's constant. If we need to know Planck's constant, it's always going to be the energy divided by the frequency. That's how our triangles can help us figure out where we are and where we need to go. The other triangle has to do with the speed of light. So to review real quick, energy is equal to Planck's constant times the frequency, and its triangle looks like this. The other one we're going to talk about is using the speed of light, which was c, is equal to the frequency times the wavelength. I'll fix my wavelength. The triangle for this one looks like this. See again on the top. On the bottom we have the frequency times the wavelength. Now let's try to apply these to the next couple of problems. Up above on this slide, you'll see some other problem-solving strategies that require you to identify in a word problem the known and the unknown. And then you can use the formulas in the middle to help you get from one point to another. In this first problem, we're being asked to calculate energy, okay? So that is this one. We're going to have a frequency. We're given a frequency. This is our given, and this is our unknown. So we can use this particular equation to help us if you decide not to use the triangles. Again, our triangle, we're using that methodology. Our E is up here, and and our Planck's constant and our frequency are here. If we're looking for energy, we would put our hand over what we're looking for, and then look to see what to do. You also will need to have some understanding of your TI 83 or 84 calculators, as well as the ones we use in class here, our TI 30s. On your keyboard, you will need to locate on the top left a key that's marked second. This is going to help you get the exponents that are involved in these equations. The other key that you want to be looking for is just above the 7 is another key that has x minus 1 on it. And above that is a double E. So when you hit the second blue button, the exponential exponent becomes useful. For any negative exponents, you also need to know on the last row of your calculator, there is something that has parentheses and a negative. That's how you make negative exponents. So for this particular problem, let's go ahead and start setting this up. And I'm going to write it as though you're doing it for your calculator. The first part is going to be recognizing that we need to find Planck's constant, which is given to us right here, and the frequency, which is given right here. So I'm going to first type in Planck's constant, 6.63, on my calculator. Then I'm going to find the second EE button and type in, find the negative sign down at the very bottom, and 34. We're going to need to hit the multiplication key and then do the same with the next number, 6.8. Hit second EE button again and put in that exponent, which is 15. And then hit enter. Your answer should be on your calculator, 4.5 084 times 10 to the negative 18th power. And that's in joules per photon. And that is our answer. When you're ready, let's move on to the next slide. So the next problem on your paper, problem number 2, is still the same as the one we did in the first problem. We're solving for energy. It says, find the energy of radiation in joules per photon for microwave radiation with a frequency of 7.91 times 10 to the 10th per second. So once again, we're being given a frequency, and we're going to need Planck's constant to solve for this, and we're looking for energy. So this is our unknown. This is our known. So on this particular activity, we're going to go ahead and again use your calculator and that second EE button. We're going to start again with Planck's constant, so E energy is going to equal 6.63. Second EE button. You're going to find that negative on the very bottom of your calculator, bottom right, and then put in 34. And hit the multiplication key on your calculator and type in our other variable, 7.91, second EE. The second EE is this times 10. You don't put the times 10 in there. That takes the place. Does everyone understand that that's what's happening here? Is that when we do that second EE button, it's taking the place of this right here. That takes the place of that times 10. And you're telling it that you want it to the 10th power. Then hit enter. And you should have gotten the following. .24. You should see on the far right a little E like that on your screen. And it should say -23. So your answer really should be 5.24, which you should write down on a test or any kind of activity that you ever do with a teacher. You still have to know that you have to translate that back into this. And don't forget your units. This is joules per photon. Now go ahead and do problem number 3 on your paper. I'll give you some time to work that problem. It's just like the first one and the second one. And if you got 1.79 times 10 to the -17 joules per photon, you have the correct answer for number 3. So now after completing your own work on problem number 3, let's move on to number 4 on your paper. You're finding the frequency this time. Once again, if you're doing the known and unknown information, let's identify what's what. Frequency here is what our unknown is. And energy, right here, is our known. Then we're also going to be using Planck's constant to help us solve for this. So energy is equal to Planck's constant times the frequency. So in our triangle, we're now looking for frequency this time. Energy was up here, and Planck's constant is here. So we're going to put our hand over the V, and it tells us that our equation is now going to be frequency, energy, over Planck's constant. So on your calculator again, you're going to be putting this time 2.39 in your calculator. Hitting the second EE button. And putting in, finding the negative sign, the bottom right, and 18. And then hit the divide key. Then enter Planck's constant, 6.63, do second EE again. Button, find the negative, and hit number 34, and enter. Your answer should be the frequency of this problem . 3.604.8. We don't really care about all those numbers. And then over to the right, you'll see a little times down at the bottom, and a 10. 15. Well, that's what you should be writing out as part of your answer. And in frequency, the units for frequency are as 1 over a second. Now on your paper, this is problem number 5. It's the problem number 4 on this slide. This is a little different. This involves two-step problems. This time we're going to be given wavelength. So we have a wavelength right here. This is our known. We're going to have to combine two different equations in order to be able to solve the answer here. We're looking again for energy, but there's no direct connection between our unknown and our known. This involves putting the two triangles together. Our first triangle is energy, Planck's constant times frequency, and our other one that we're going to need this time is the speed of light, c, over frequency times wavelength. Okay, we're given wavelength, so we're going to enter here. We need to find the frequency. This is what we're trying to find. And our link is going to be here, between the two frequencies, between the two triangles. So first stop, given c, our speed of light, is 3 times 10 to the 8th. Again, you're doing your second EE button here, to the 8th power. And then you're going to do divide by the wavelength given in the problem, which is 5.89. I'm going to do second EE button again. Find the negative sign at the bottom right. 7 power. Put the 7 in there after that. Hit enter. So the first half of this, which solved for frequency, answer is 5.09. You should see a little times 10 on the bottom right, 14 power on your calculator. It's 5.09 times 10 to the 14. Not done yet. We now need to plug this in to our energy diagram where we're trying to find energy. So we're going to put our hand again over E this time, and we have to look here to see what to do with our frequency, and that means multiplying by Planck's constant. So we have frequency, so now we're going to use Planck's constant, 6.63. Remember, do second EE button. Find the negative sign at the bottom right of the key. Hit 34, and then hit enter. And your answer then for energy, give yourselves a moment to look at that and then check your answer against mine. I'm going to grab my calculator and do the same thing. I get 3.37, more than enough significant figures, times 10 to the minus 19. And use units for energy, again, joules, proton.